Hey Ramblers. Way back in September, in Chapter 2, we learned what it meant for two lines to be perpendicular. In fact, it was probably something that most of you already knew before even getting to the class. But now we're going to ask, what does it mean for a line to be perpendicular to a plane? So for instance, if we looked at these pictures here, is the lamppost perpendicular to the ground? It looks like it is. How about that telephone pole to the left? Is that perpendicular to the ground? How do you know? Well, after watching this video, you should be able to define what the perpendicularity of a line and a plane means. It's not the same as perpendicularity between two lines, and you should be able to apply it to problems. So please take careful notes, pause often, and thanks for watching. I hope this helps. Okay, so what exactly does it mean to say that a line is perpendicular to a plane? Please get this in your notes. A line is perpendicular to a plane if it is perpendicular to every one of the lines in the plane that passes through its foot. So, if I know that QR is perpendicular to M, then I'm sure that since line J passes through point P, that it's perpendicular to line J. If I came up with a second line, line K, I could be sure that QR is perpendicular to K. I could come up with an infinite number of lines that are in plane M that pass through P, and it will be perpendicular to all of them. So once you know a line is perpendicular to a plane, you know that it's perpendicular to an infinite number of lines in the plane passing through its foot. And that's a lot of information in a simple statement. All right, well, so how then do we prove that a line is perpendicular to a plane? And that brings up the theorem. Please get this in your notes. If a line is perpendicular to two distinct lines in a plane that pass through its foot, point P, then it is perpendicular to the plane. In other words, if QR is perpendicular to J and QR is perpendicular to K, then it is perpendicular to the entire plane. So, if you can prove that a line is perpendicular to two lines in the plane passing through its foot, then it is perpendicular to every line in the plane that passes through its foot. So you get two, and you get all of them. Okay, well, how does that relate back to the picture of the lamppost and the telephone pole in my neighborhood? Let's take a look and we'll conclude the video. This picture was taken in my neighborhood of a lamppost and a telephone pole on Hunter Street as I'm looking west. And from the picture, they look as though they are perpendicular to the ground. In other words, the ground is the plane, and each of these represents a line. Now let's take a look what happens when we look at it from a different angle. Is it still going to appear to be perpendicular? Here's a picture of the same lamppost and the same telephone pole, but now I'm looking south. So it's almost like I am looking at a different line passing through their foot of each of these two lines crossing the plane of the Earth. And it's pretty clear now that I get another perspective that the lamppost does have now two lines passing through its foot. The one from the previous picture and this picture, but the telephone pole does not. While the other line in the previous picture made it look as though it was perpendicular to the Earth. When we look at it from another angle and a different line passing through the foot of the telephone pole, it's clear that it's not perpendicular from this angle. So therefore, it's not perpendicular to the plane of the Earth. Okay, Ramblers, thanks for watching. A quick tutorial on a problem that's important in this section, and then we'll conclude. Thanks for watching. Number 8 on page 279 is an important problem in this section because it gets to the heart of showing that whether or not a line is perpendicular to a plane. So they tell us that AB is perpendicular to BD. Therefore, we know that angle ABD is equal to 90 degrees. From the given that angle ABD equals 2/3 x plus 56, I can solve for x. So x is 51. Now they want to know, is AB perpendicular to M? Well, if it is, angle ABC, which is a distinct, BC is a distinct line in the plane other than BD, and if it is a right angle, then we know that AB was perpendicular to M because AB would be perpendicular to two distinct lines in the plane and therefore would be perpendicular to the whole plane. So let's plug 51 in for x. It tells us that ABC equals 2 times x minus 10. Is that equal to 90? When we plug in 51 for x, it's clear to see that 90 does not equal 92. So therefore, since angle ABC is not a right angle, then AB is not perpendicular to two distinct lines in the plane. Therefore, it's not perpendicular to the entire plane. Okay, Ramblers, it's really important that you're able to learn the definition and to apply it. And the trick is to check that the line forms right angles with more than one line in the plane passing through its foot. Okay, Ramblers, thanks for watching.